now I'm going to give you a multivariable optimization problem. You can't really use single variable calculus to solve it because two things are varying at the same time. So let's say you're a farmer and you've got a fence that is 100 meters long, 100 meters long, and this is the wall here. You're trying to maximize the area. This length must be the same as this length, so whatever's left is actually 100 take away 2x, and you can vary the angle. So two things are varying at the same time. You can choose a length and you can also choose the angle, because you can make x to be really big like this. So the whole length here is 100 meters, but then you at the same time you can also vary the angle. You can also vary the angle like this. So you can change two things at the same time. You can change the length x, and you can also change the angle. You can also change the angle. Well, find a value of x and a value of the angle where it will give me the biggest area. So press pause and have a go. Okay, so to do this, we need to come up with a function. So the area is given by this. So if you for any given x, hang on. So this is a right angle triangle here. This is of length x. So this must be x sine theta. This length must be x cos theta. So this area here plus this area here will be this times this. That will then give us this thing here, this times this, and then this area here will be given by this times this. So that would be given by this times this thing here. So the area is given by this, and then tidy this up. That will then take us to here, because whenever you have sine, and cos, whenever you have sine and cos, you can replace it with this thing here. So anyway, tidy this whole thing up. That will then give us this thing here. So we've got a surface. Our surface is given by this. To find the critical points, in our case it should be point. There's only one, should only be 1 point. So we need to find the critical points. To find the critical points, we demand that you partially differentiate it with respect to x, and we demand this to be 0. We demand you partially differentiating it with respect to the angle, and we demand this to be 0. Hang on, we demand this to be 0, and then let me think. So looking at this, let's partially differentiate it with respect to x. That will then give us this thing here, and then hang on, bear with me. Alright, that will then give us this thing here, and then let me think, and then it's blah blah blah. That will then take you to here. We demand that this thing must equal 0, because we're trying to find the critical points. Critical points occur when this equals 0 and this equals 0. So we want this whole thing to be 0. So set this to be 0. That will then take us to here. So now simplify it. Divide everything by sine theta. So divide this by sine theta. When you divide by sine theta, at the back of your mind, you can't really divide by 0. But then if you look at our problem, you can't really have an angle of 0, because our fence, this is our wall here, our fence cannot have an angle of 0, and it cannot have an angle of 180 degrees, because it would be flat. It won't give you an area. So this is okay, even though you can't divide by 0. In our scenario, it should be okay. So divide everything by sine theta. This whole thing here will then become this. Now we need to look at theta. So if you partially differentiate our surface with respect to theta, it should give you this. So now we demand that this thing here equals 0. So that will then take us to here, and then we can simplify this by if you look at this, by dividing everything by x. So divide 0 by x, and then at the back of your mind, you're not allowed to divide by 0, but then in our scenario you can't have a fence of length 0, so we can ignore this. So divide everything by 0. That will then take us to here. So so as a summary, we need to solve, in effect we need to solve these two equations simultaneously. So to solve these simultaneously, we need to think, looking at this, rearrange this to make this a subject. So add 4 to both sides, and then take away 10, take away 100, and then divide by 2x. So so looking at this, cos theta is this thing here. So cos theta is this thing here, and then we can put this. We can now put this into here, into the second one, and then this is quite annoying. So we would use a double angle here. So looking at cos 2 theta, we can put this into here. So so that will then take us to, hang on, let's start again here. Let's start again here. This thing here, we can put this into this block here. That will then give us this thing here, and then we can put this into here. That will then give us, well, when you put this into here, it will then give you this thing here, and then put this into this cos here. So that would be this thing squared, this thing squared. So I hope you can follow that. We are well, from here that will then take you to here. So now we are in effect trying to solve these two simultaneously. We've got to find x and theta such that both of these will be satisfied. So so that will then take us to here, and then we can simplify. Multiply everything by x by 2x, so that this whole thing here will then become this thing here, and then multiply this out. This times this, that will then give us this. This times this, that will then give us this. This times it, and so on. This whole thing here will then become this, and then tidy this whole thing up. That will then give us. That will then give us this thing here. X factorize out the x, that will then give us this thing here. So either this is 0 or this is 0. So so x equals this thing here, which you can simplify it to this. So now we've got our x. So from above earlier we had this thing here, cos theta equals, if you scroll up all the way up, we had this earlier. So now that you know x, you can put it into here to find the angle. So put it into here, put it into here, that will then take you to here, and it turns out to be, well, if you tidy this whole thing up, it will be a half. So cos theta equals a half. Visualize your equilateral triangle of length 2, cut it down the middle. This is of length 1. Cos theta is this angle here, which happens to be 60. Well, the angle is 60. So what that means is, if you're the farmer and you have a length of 100, what you do is you get your whole length, cut into 3 equal pieces, and then somehow form an angle of 60. That will give you your biggest area. Okay.